Alright, this video is on solving what are called multi-step equations. Equations are considered multi-step equations either because there's simplification that needs to be done or because there are variables on both sides. Now, as far as simplification is concerned, you recognize the need for it if you see like terms on the same side of the equation, if you see parentheses, if you see exponents, etc. So you're looking for order of operation things. Variables on both sides are easy to spot, of course. Okay, so our first equation is solve 2y minus 7 plus 5y equals 0. Well, typically when you're solving linear equations, you should have at most 2 terms per side. This particular equation has 1, 2, 3 terms on the left and 1 term on the right. Well, so something needs to be simplified here on the left. 2y plus 5y simplifies. Those are like terms. We add them by adding the coefficients of 2 and 5 and get 7. So we have 7y, recopy the minus 7, recopy the equal 0, and now what you have is a common two-step equation. Now remember, there's only one rule for solving equations, and that rule says that you have to do the same thing to both sides of the equation, or I should say that you're allowed to do the same thing to both sides. If I add 7, positive 7 is the opposite of negative 7. When I add them together, I get 0, leaving the 7y. Now that's certainly progress. So because the one rule says I have to do the same thing to both sides, I'm going to add 7 to 0 as well. And I get the equation 7y equals 7. Now I need to do the same thing to both sides. My goal, of course, is to have y by itself. 7 is the coefficient on y. If I put a 7 underneath that term, I get 7 divided by 7, which makes 1, which is what we want. So dividing by 7 works. So we're going to do it to both sides. 7 divided by 7 is 1, and y equals 1 is the solution of the equation. Our next example, 2.4 equals 3 parenthesis m plus 4 close parenthesis, needs simplifying because, please excuse my dear Aunt Sally, we have parentheses. So we're going to go ahead and attack the parentheses by using the distributive property. The 2.4 stays the same. 3 times m is 3m, and 3 times positive 4 is positive 12. We now have a common two-step equation. Now you will notice, of course, that the variable happens to be on the right, but that's okay. Our goal is to have that variable by itself. The one rule says if I do it to one side, I have to do it to the other side. So I'm going to subtract 12 from both sides. Why? Because 12 minus 12 is 0, leaving 3m by itself. 2.4 minus 12 is negative 9.6. Now my goal is to have m by itself or with that invisible coefficient of 1. Since 3 is multiplied by m, I'm going to divide by 3 to make my 1. 3 divided by 3 reduces to 1. 1m equals negative 9.6 divided by 3 is negative 3.2. So my solution is m equal negative 3.2. Now I'm going to show you another way to solve this equation because remember there's one rule. So as long as you don't break that one rule and you have some reasonable thought process behind your choices, you can find the solution another way. The 3 is being multiplied by the quantity m plus 4. So I'm going to divide the right side by 3. Now when I do that, 3 divided by 3 makes 1, which is a good thing because then the number in front of the parentheses becomes 1. 2.4 divided by 3 is 0.8 equals, and since the coefficient on m plus 4 is 1, I can drop the parentheses because they're no longer necessary. Now I can subtract 4 from both sides because 4 minus 4 makes 0. That leaves m by itself, and 0.8 minus 4, which is negative 3.2. Now, you can use either one of those techniques. Notice that this first technique, let's count the steps. We had a distribution step, we had subtract 12, and we had divide by 3. In the second technique, we had the divide by 3 step and the subtract 4 step. So this was 3 steps, and this was 2 steps. The answer is the answer, regardless of which way you go about it. So you can choose. Just don't break any rules. Don't do anything wrong. Easy for me to say, right? Okay, next example. 5 times the quantity, 1 minus 2w, plus 8w, equals 15. All right, on the left-hand side, we definitely have simplification because we have parentheses. So that's going to be the first thing we attack. 5 times 1 is 5. 5 times negative 2w is negative 10w. The parentheses are gone because I did what they told me to do. And now I'm going to recopy the plus 8w. I'm going to recopy the 15. Now, I have 3 terms on the left-hand side, right? 1, 2, 3, which means there's more simplifying probably. Negative 10w and 8w are like terms, which means they can be combined. I'm going to recopy the 5, and then I just do negative 10w plus 8w, which is negative 2w, and I recopy the equals 15. Now we're at that 2-step equation process where we have the rule which says I have to do the same thing to both sides. I need w, my goal is w equals. So the 5 and the negative 2 have to go. I'm going to subtract 5 from both sides because 5 minus 5 makes 0, so that term disappears. I have negative 2w equals 15 minus 5 is 10. Now the negative 2 is being multiplied by the w, so I'm going to divide by negative 2 because negative 2 divided by negative 2 is positive 1. So I divide the right side by negative 2, and 10 divided by negative 2 is negative 5. And there is my solution. Next example, negative 3x minus 8 plus 4x equals 17. You can see on the left-hand side we have 3 terms, which indicates some possible simplification. If you examine the left-hand side, you'll notice that we have like terms. So we combine them. Negative 3x plus 4x is x. Recopy the minus 8, recopy the equals, and the 17. We now have a 1-step equation. Our goal is x equal. The problem is the minus 8. When I add 8 to negative 8, I get 0 because they're opposites. If I get 0, that means I can cross them out. And I get x equals 17 plus 8, which is 25. Now, so far all of our examples had a side that needed simplifying. Let's try a problem where the two sides are as simple as possible, but we still have a multi-step equation. Solve 4x minus 5 equals 2x plus 7. Well, 4x minus 5, those are not like terms, so that cannot be simplified. Note, if you just want to count, you have two terms. On the right-hand side, 2x plus 7, those are not like terms. I have two terms. I can't combine them. This thing is as simple as it gets, so we have to proceed immediately to solving. Now remember, there's one rule for solving. If you do it to one side, you have to do it to the other side. Same thing. I need my x's. I need to have x only on one side of the equation. So what I want to do is move the 2x by taking it away from the right side and putting it on the left side. Now why does that work? That works because 2x minus 2x is 0, leaving the 7 by itself. 4x minus 2x is 2x. 2x minus 5 equals 7. And now I have a two-step equation. So I'm going to move the 5 by adding 5 to both sides. Negative 5 plus 5 is 0. 2x is by itself, equals 7 plus 5 is 12. 2 is being multiplied by x, so I divide both sides by 2. Why? Because 2 divided by 2 is 1. And I get x equals 6. And that's the answer. All right, next example. 5 plus 3, parenthesis, x minus 4, close parenthesis, equals 2, open parenthesis, x plus 1, close parenthesis. Now, this particular problem needs simplifying on both sides, and we know that because there's parentheses on both sides. So on the left, I'm going to distribute the 3. On the right, I'm going to distribute the 2. Notice the 5 is not involved in the distribution, so I'm going to recopy it. 3 times x is positive 3x. 3 times negative 4 is negative 12. Notice the parentheses are gone. 2 times x is 2x. 2 times 1 is 2. Now I still have simplification to do on the left side because I have 3 terms. The right side only has 2 terms and they're not alike, so the right side is ready to go. On the left, I have like terms of 5 minus 12. Those are both constant terms. 5 minus 12 is negative 7. Recopy plus 3x, recopy the equals, recopy the 2x plus 2. I'm ready to start solving. Now the only rule is do the same thing to both sides. So the first thing I'm going to do is take the 2x off the right side because I want it on the left side. Notice I'm doing the same thing to both sides. I get negative 7 plus 3 minus 2 is 1x equals, that cancels, and then you're left with just a 2. This is a one-step equation now. I'm going to add 7 because negative 7 plus 7 is 0. And since negative 7 plus 7 is 0, I can cross it out, leaves x by itself, and 2 plus 7 is 9, x equal 9 is my solution. So, come on, it's not scrolling. My next example is 5 minus, open parenthesis, n minus 4, close parenthesis, equals 3, open parenthesis, n plus 2. Notice again, since I have parentheses on both sides, I have simplifying that needs to be done on both sides. We need to acknowledge the presence of the negative 1 in front of the parentheses on the left. That negative 1 needs to be distributed. On the right, we have a 3 that needs to be distributed. The 5 is not involved in the distribution. Negative 1 times n is negative n. Negative 1 times negative 4 is positive 4. 3 times n is 3n. 3 times 2 is positive 6. Now, because the left side has 3 terms, I've got more simplifying to do. The right side has no more simplifying. On the left side, I have a 5 and a plus 4. Those are like terms which combine to make 9. Recopy the minus n, the equals the 3n plus 6. I'm now ready to actually solve the equation. There's one rule, do the same thing to both sides. I'm going to be crazy, and I'm going to move the n. I'm going to add n to both sides. Why? Because negative n plus n is 0. That leaves 9 by itself. 3n plus n is 4n plus 6. Now I'm going to, my goal is to have the n by itself, so let's just acknowledge that right now. So I have to move the 6 and I have to move the 4. I'm going to move the 6 by subtracting. 9 minus 6 is 3 equals 4n. And 6 minus 6, of course, is 0. I'm going to make some room for myself. Then I need to go ahead and move the 4 off of the n. The 4 is being multiplied by n. So I divide both sides by 4. Why? Because 4 divided by 4 makes 1. That leaves me with n equal 3/4. Or if you're using a calculator, it might return the answer, 0.75. Okay, that one's finished. And let's see, I have, looks like just one more example. We're going to solve 5 minus x minus 2 equals 3 plus 4x plus 5. I don't have any parentheses, but notice I have 3 terms on the left and 3 terms on the right. And at this stage in algebra, that usually indicates that you need to simplify. We have 5 minus 2. 5 minus 2 is 3. Recopy the minus x, the equals. On the right, I have 3 plus 5, which is 8. Recopy the plus 4x. We're now ready to move things across the equals. I'll move the 4x this time. So I'm going to subtract 4x from both sides. Why? What is 4x minus 4x? It's 0. Okay, so the 8 is by itself. Recopy the 3. Negative x minus 4x is negative 5x. This is a two-step equation. I'm going to move the 3 by subtracting. Why? Because 3 minus 3 makes 0. That leaves the negative 5x by itself. 8 minus 3 is, 5. And now, since negative 5 is multiplied by x, I'm going to divide both sides by negative 5. Why? Because negative 5 divided by negative 5 is positive 1. X equals 5 divided by negative 5 is negative 1. And there's my solution. All right, so when you're working with equations, you really want to examine the two sides of the equation first. If either of those expressions has parentheses or like terms, you need to take care, well, you don't have to take care of that first, but I recommend you take care of that first. Get the equation down to as few terms as possible on both sides before you begin using that one rule that says you do the same thing to both sides of the equation in order to get the variable by itself. Thank you for watching.